Okay guys, so in my first video, I spoke about the braking cycle and the gas turbine having a relationship. But also what I do want to start with is I want to continue on that subject, but before I want to go through the first and the second laws of thermodynamics, because these laws are very important especially in your first year when you're doing engineering and you have a thermodynamic module. These are very important. So I'm just gonna explain them, and then as I do more videos I'll apply them, and they should make sense as they're being applied to whatever other cycles or whatever thermodynamic concepts that I do bring up as we go along. So the first law is the law of conservation. Basically, this law explains that energy can never be created or destroyed, but it's simply transformed into another form. So that's the first law. Energy can't be created or destroyed, but it's simply transformed into another form. In contrast, the second law states that for any cycle in which heat is applied into the cycle, if this cycle undergoes any kind of work output, heat must always be rejected. So if this cycle has any sort of heat energy input in that cycle, as long as that cycle goes through any kind of work done on it, then there's always going to be heat rejected. And both laws can be applied to heat engines, such as the gas turbine or, for example, a diesel engine. So what is a heat engine? A heat engine is basically a system that simply converts chemical and thermal energy into mechanical energy. So, like with the chemical and thermal and mechanical energy I mentioned that they're all forms of energy that support the first law of thermodynamics. As for example, in a gas turbine and other types of engines, chemical energy is always in most cases transformed into thermal energy, which is always then transformed into mechanical energy. Now, in regards to the second law, not all the heat produced in an engine can be converted into work, as it would make the efficiency of the engine 100%, and that's not possible. That's what the second law is explaining, that there's no way you can achieve 100% efficiency in an actual system that work is being done on or done by. So if you remember when I spoke about the ideal cycle, in an ideal cycle you have the processes are reversed, but in a real cycle they're not reversed. So in this case, the second law is talking about what is actually happening in a real cycle. If work is being done by the system, in that, for example, if I put fuel in an engine, as long as that engine doesn't undergo any kind of work, so if I don't start the engine, if I don't move the car while I start the engine, if I don't do anything with the engine, there's not going to be any losses. You see, so nothing is going to happen. You understand? You don't lose any heat, you don't lose anything, you don't lose any fuel. However, once that engine begins to run, once the engine begins to use the fuel energy to work, then heat has to be rejected. So once I start driving that car, once that fuel is being utilized as work, then the engine is not working. So the heat now has to be rejected. I mean, can you just imagine having a system, right? Having your engine and being able to utilize all the fuel that you've put in your car, and basically there's no space or there's no hole for the heat that's been formed by the burning or combustion to leave the exhaust. So everything is within the car. How is that possible? It means that the car will probably explode or something. There needs to be heat energy leaving the car. If not, there will be an explosion. So as a result, this is what the second law is basically proving, that we can't achieve 100% efficiency in a heat engine, because heat always has to leave. Heat always has to be rejected to keep it running. And when this happens, this is when we have something called waste heat being produced. And waste heat is basically the heat that's not being utilized by the system. So the heat that's being wasted, the exhaust, what's coming out the exhaust, and in a car situation, it goes to the exhaust and also to the coolant system. So these are the waste heats system. So the second law is basically telling us that waste heat is always going to be there no matter what, because heat has to be rejected because the system has done work. Yes, guys, that's it for the first and second laws. If I haven't really explained it properly and you want me to explain it more, please let me know in the comments below. But yes, guys, next video will be, I'll still be applying the laws of thermodynamics, but I'm going to go into some thermodynamics cycles which will be applied to all these laws to hopefully help people understand. But just send me a message or a comment and just let me know what you want me to do videos on also. All right, guys. Bye-bye for now.